Yeah. Hi, everyone. My name is Erik. I work as head of development for an agency up in Stockholm called iTeam Solutions. Before I became head of development there, I used to freelance and did a lot of work on Android. I've been working with Android on and off since 2008, which basically means since it was launched. And I've worked on everything from like the regular apps that we download from Play Store and et cetera, et cetera. So who else here is an Android developer, mostly? Yeah, cool. So not everyone, that's great, because I'm going to cover a lot of basic stuff as well, but hopefully that even those of you who are Android developers, you might find something new and interesting here. So when I'm not writing Android apps, I'm also building apps for Stockholm public schools. So I'm also one of the creators of the Öppna Skolplattformen, which got featured in Wired. So yeah, that's on the bucket list. Anyway, and to be fair, this was is a React Native app, so it's not a native Android app. Still okay. So it's been a while since Android was released, and when we started, we used Java, we used Ant for building, and we used Eclipse. Anyone still stuck on any of these? I'm very sorry. You might have some Java left in your project, but by this time you should at least have started migrating everything to Kotlin. Anyone remember how it was to work with Eclipse? Also know that it required constant restarting. It was like a huge problem for any Android developer. It was just very buggy. So they switched and they changed everything now, basically. So now we use Kotlin instead. We use Android Studio, which is a JetBrains tool based on JetBrains IntelliJ, and we use Gradle for building. So everything is more up-to-date, modern, etc., etc. And a lot of this presentation is going to be around Kotlin, because it's kind of what makes Android development fun these days. Yeah, so let's get started. Kotlin. So who here writes Kotlin besides doing it on Android? Yeah, some of you actually use it elsewhere as well. So you can run Kotlin pretty much anywhere. You can run it in the browser. You can compile it to JavaScript, run it in the browser. You can run it on a JVM in a backend. You can run it on desktop. There is a desktop compile target there as well. You can run it on Android, of course, because it compiles to the same bytecode that we used to for Java. And it also compiles to native binaries, which means it works on iOS as well. We're going to focus on the Android part, but I'm going to go back to this multi-platform thing a little bit later. So for those of you who are new to Android, or Kotlin, but you've done Java programming, you've probably done something like this. You just want a plain old Java object, and you generate the getters and setters, and you generate the hash code equals, and you generate the toString, and it's just a lot of boilerplate for very little functionality. I know that you can do it better with later versions of Java, but still, this is something we are kind of still stuck with when using Java in many ways. It's a lot of very verbose language. This is how you do it in Kotlin. The data classes is one of my favorite features there. And it's not just favorite feature because of the compact piece of code you get. It adds stuff that you don't find in Java. You can make things optional, you can make things have default parameters, etc., etc. And speaking of default parameters, let's say they have this class, and it has a bunch of parameters, but some of them should be optional, and some of them should have default values. So you need some kind of builder pattern to do this. Kotlin comes with a builder pattern built in for any class. And it's super simple to use. Basically, you just, in the parameter list, you just assign the default value. You can also mark it with a question mark to make it optional. Like that would mean it can be nullable. And by making some of the arguments have default values, you don't need to specify them when you're calling this function, which is kind of neat, because things get much, much simpler. So creating one of these objects, and you just have to provide the title, because the title is the only mandatory parameter in the constructor list. This makes things simpler. We don't have to perform null checks ourselves in the constructor. We don't have to have a complex logic with multiple implementation of constructor, depending on how many parameters we have. We don't have to create a builder for creating these objects. So everything gets really simple to build in a safe way as well. Okay. Sealed classes. Anyone here used sealed classes in Kotlin? Okay, so you know how cool this feature actually is. Basically, it's a combination of enums and inheritance. So when you declare the sealed class, it becomes an abstract class. And you can extend this class as you do with normal inheritance. But the compiler will, from now on, know what possible subclasses there are. Only those subclasses that you have defined in your code here at compile time. So in this case, we have a data class that we call stuff that extends from thing. We have a regular class which has a function called gadget, and then we have a singleton. You can define singleton in code. It will just be one single instance of that one using the object keyword, and that's that one. So there are three classes or three classes that can have extends from thing. So why does this matter? What makes this better than just regular inheritance or having enums where you add functions? So, well, these are regular classes, so they're more powerful than enums. And you can make exhaustive checks, so you don't need to have else branches. So let's say you have this thing here, you have handle thing function taking the thing parameter. When is the Kotlin equivalent of a switch case? And there's only three possible cases. There is no default case ever happen, because the compiler knows that it's only these three subclasses in existence. There will never be anything more during this compile time check. And this makes your code more safe, so you don't have to bother about like would be the default or the else clause in these cases, and generally just improves your code quality, because you get a type checking already at compile time for all possible variations. So coroutines is a feature in Kotlin as well. And the easiest way to explain it is, for someone who writes JavaScript, is the equivalent of async await, but it's much, much more. Async await is basically just syntactic sugar on callbacks, basically, or promises. Coroutines is basically an engine by itself, where it transforms your code at compile time and adds suspension points. A suspension point is where the virtual machine can take a state of that function call, store it, and then pick up another coroutine and run that one instead. This concept exists in many different languages. If you use Go, you have Go routines. If you use Elixir, you know what I'm talking about, etc., etc. It's a super powerful feature for handling concurrency. And yeah. So why does this matter for Android or Kotlin then? So this is a typical way to declare an API call. You use the retrofit library. And up until we had coroutines, a lot of us relied on RX Java. Anyone here still using RX? Yeah. Okay. Reactive streams, basically. And in this case, you know it is an HTTP call, so it's a single event that comes. So we have a single of the type user that's going to be returned here. Retrofit handles the construction of the HTTP call by filling in the path parameter and returning, deserializing the data properly. Now, if you have an API like this and you're going to use this in your code, especially in your UI somewhere, maybe there is a view model in between, but let's skip the view model for now. It will look something like this. So because if it's an RX, you get a subscription, and you need to unsubscribe that one as well. So what you need first is to make the call, and then you know that this call must happen. I see. No, I have them the right way. So you have to enforce this network call to happen on an I/O thread. That's important because you can't make network calls on the main thread. That will block the UI. But since we need to update the UI here, we need to switch back to the main thread. So you need these to subscribe on and tell what thread you're going to subscribe on, and you need an observe on telling you to go back on the main thread. Regular Rx operators. Anyone used Rx before, you have probably seen this. And then you have disposables, which is just like something where we keep the subscription here so that we can cancel it when the activity goes away, when you back out of the application. Which is important, because if we didn't do this clear here in the onStop function, this call would still happen if the network call would finish once the application is in the background, and it will try to update the UI when the application is in the background, which means it will crash. The user wouldn't notice anything, but then when they come back, they would get to the starting point of the app again. It's an unpleasant experience, etc. So anyone used this have probably forgotten to do a clear at some point. Very common error. So this became a very error-prone way of doing it. Now there are other libraries that help you deal with this. There are lint checks that say you forgot to call clear, but overall it wasn't a very pleasant experience because you also had to do this thread management, etc. So with coroutines, that goes away. So instead of having a single, you just have the regular return value of the user, but you add a suspend keyword in front of it. And now, this is all you need. So you call the lifecycle scope. That's a coroutine. That's a scope that the coroutine runs in. It is tied to the activity by default. So the activity exposes this lifecycle scope property. And the launch function is basically start my coroutine. Call that one. We can get the value immediately. And then we can update the UI. All in the same call here. We don't have to switch threads because a suspend call on a retrofit function knows that it's going to run on the IO thread. It will handle that part automatically for you. And since you're launching this and you're not specifying a thread, it will do it from the main thread, so you're safe to update. Furthermore, lifecycle scope will automatically cancel any coroutine launched on it once the lifecycle goes away. That means when the activity stops. So this is safe. It's much safer code, less code, and just much easier to use. With coroutines, there also comes a bunch of libraries on top for doing reactive operations, etc., similar to Rx if you need to do that. Yes, Kotlin multi-platform mobile. Anyone had a look at this yet? Tried it out? One person down there, a few. Okay, it's pretty cool. Basically, it takes a whole cross-platform thing that we have for mobile, where we used to doing the UI in one language, and then it just compiles down to 2 apps. React is doing that, Flutter is doing that. Problem with those is that they embed an entire runtime in your app for that specific framework. There is a JavaScript engine running in React app, there is a Flutter engine running in Flutter apps. It adds overhead. Kotlin multi-platform twists that around. It starts from underneath instead. It lets you write the code in Kotlin all the way up to the UI, but there you stop. So you share everything underneath the UI code. And it compiles natively to each target. So it compiles to regular Android code on Android and to the native code on iOS. Big diagram from their site. But basically, this is how you divide it. So everything that has to do with data, storing data, or fetching data, etc., goes into the Kotlin code. And the upper part is just Swift on iOS or Kotlin Compose and Kotlin on Android. Okay. Bunch of libraries are already available as Kotlin multi-platform versions. Ktor is the network library, and that is coming strong now, kind of replacing what Retrofit did in the earlier slides. There is dependency injection, serialization, basically from JSON to data classes. SQL Delight, which is a wrapper on top of both core data and SQL databases in Android, etc., etc. You can even do GraphQL with Apollo if you want to on a Kotlin multi-platform project. So this is nice. It is probably very useful if you're starting up a new app today. I think it might be hard to migrate to this for an existing code base, but it's a really exciting thing to see that we're going we're getting native compiled targets through cross-platform still. Jetpack Compose, and this is what I think is the most exciting thing about writing Android today, because while it's similar to what React and Flutter and Swift UI does, it adds so much more. I'm not going to go into the very deep details of Compose. There are much better talks online for that, and tutorials and stuff. And I can have a complete afternoon just talking about the stuff in Compose. So we're just going to look at parts of it so we all get a grasp for how it works. Anyone done React here? Yeah. So everything, I'm going to use React as a comparison for this. Sorry. So the old way to do it was basically we had our activity, the first screen, and we called set content view, and we gave it an XML file. I was like, okay, what's wrong with that? Well, the XML file looks like that. And that's just the core wrapping stuff. The actual content goes into another XML file there. So yeah, it was hard to do this. Sorry, my microphone is busy. Yeah, so we used this for a long time, for like more than 10 years. And then they finally made Compose for us. And the way to do Compose is this. You still call the set content. Yeah, there, better. You still call set content, but instead of taking an XML file, it takes a composable function. A composable function is very much similar to the React widgets, the React functions that we do today to get a React component. And we can pass modifiers to it, which just modifies the properties of that thing. The way it works underneath, it's basically during compile time, it has an API in the compiler where it fetches all these calls, transforms the code, and actually creates a graph, a UI graph underneath. You never see that part. You only work with this code. A composable function looks like this. This would be a list of cards showing the weather at certain cities. We pass a view model to this function. And from that view model, we fetch the state of all. We get all the cities that we are collecting weather information from. We collect that as a state. This is very much similar to a reducer in React, or use state if you want. And then we have a scaffold, which is like the top part of the UI. We have a column first, where we add a lazy column. And here I'm wrapping two things, and you might wonder, why are you not just using a single component there? Well, it doesn't cost anything. You can have, as opposed to the XML layouts we use for Android, it's very costly to have a deep hierarchy, so you try to avoid that, you try to flatten it. Compose does not have this problem, because these are just function calls that happens, and they're very, very fast. Lazy column is basically a lazy loaded list. It has, when you call that one, you get access to another function called items, where you pass in the items here. And then for each of those items, we add we make another composable function that represents that actual card. And here we also have the first example of a local state in a composable. So we basically call var expanded by remember, and that is the same thing as use state in React. We say that it's immutable state of false, and then we add a clickable callback on each card where we just flip this Boolean. And the redraw will happen whenever a parameter to a composable changes. So if you click a card, only that card will change, not the whole screen. Another interesting thing, what they did with Compose was how they removed the limitations for what we can put into, how we can combine stuff, or rather how we can compose a UI. With the old XML layouts on Android, we were sort of like, yeah, this is a toolbar, it can only have a text and maybe a button. And we were very, very limited to what we could do with the default components that came from material design. Compose does not have that problem. In this case, we say, well, this is a top app bar, and it has a certain look and feel, but the content of the top app bar can be anything. You could have a list in there if you want to. There is no limitation to what kind of composable function that you can call in these. Same thing here. Yeah, so in this case, I just passed a city card here, but it could be any other composable. You can have like this lazy column here is a column scrollable list. You can add a horizontal scrolling list there instead if you want to. So you're very free to compose your UI as you wish. So yeah, so this is an example straight off from the developer site for Android. It's basically like an image, and then there's the text underneath, and the text is only visible if you have clicked the image or on this column, basically. So one important thing, and anyone worked with React knows, it is very nice that you have like this constant live feedback. So you could have the website there, and you could have the code editor there, and anytime you make a change, it just updates automatically. That's nice. It's a little bit more difficult when it comes to apps because it needs to be compiled and installed. They're working on that also, but they added a preview thing, which is, yeah, there. Looks like this. This is how the UI looks like. So you have that in Android Studio. All you need to do is you declare a function that's annotated with preview, and it will render this in the preview view live for you. You can even switch it to enable interaction. So if you have a clickable, it will call that function, etc. That's very nice. So you get a really fast feedback loop for working with composables like this. Side effects. Again, comparing to React, you have the use effects. In Compose, it's called launched effect. The difference, the main difference here, and the main advantage of using Jetpack Compose is that launched effect is a coroutine, so you can do async functionality here. So you're not limited to having to do regular synchronous calls. So in this case, basically what we do is we show a snack bar once when it's depending on the state of the snack bar here. And this is important because what launched effect also does, it's tied to the life cycle of this composable. So whenever this goes off the screen, we remove it. It will cancel the coroutine, and it will remove this snack bar that pops up from underneath, which is a nice way to deal with stuff, because that's another thing. Showing snack bars or pop-ups, etc., they should be automatically canceled when the UI goes away. Side effects, more about those. Let's say here you want to animate between two colors. You have like a Boolean saying that which color you should show. That works well. You don't have to do much here. But another place where side effects is necessary, let's say that you want to start with the color gray. So you do like that. Is get a color, which is an animatable color. But you want to change this depending on another parameter that comes in and might change later. So when the parameter changes, that will be a side effect, and you need to use launch effect like this. It's another use of that. Generally speaking, you should avoid side effects. That goes for any language, basically, any code you write, but sometimes you actually need it. So good to know how it works. Animations. They have a nice diagram that is easy to follow. No? Okay. Yeah, at least it's... You could follow this and figure out which animation function you should use. I guess it's useful that way. But let's look at code instead. So the most simple type of animation, we want to show something when we switch a Boolean. So we have if something is editable, if that is changed, we should show this text, otherwise not. So animate visibility, visible if editable is true. And when you click on that one, you toggle it off. So, and it will just fade away. The default animation is just fade away. You can configure this animation by basically combining multiple types of animations and configure those individually as well. So you can do some complex animations on this visibility change. What more? Animate star AsState, and that basically a primitive or an object. You can animate that one. And in our case, let's say the alpha, the transparency of a component. You want to animate that one. Then you use animate float AsState. And in your box or component where you want to have it become transparent, you basically give it the alpha state here. And it will just redraw this automatically for you. So there's no animation added to the actual box. It's just a property that you pass in. Transitions, well, that's bigger animations. You want to change the size of a component. And this is a typical thing. You have a box, and you want to basically go from nothing and go big when something happens. What you do then is you create an update transition, and then you give them 2 states, and it will animate between those 2 states. So it's really simple to do very complex transition animations with Compose, but you need to understand the API. So this one is actually necessary to check out sometimes. I haven't remembered all of these yet. Okay. Material design. It's important to mention that one because they are doing material design both for the old XML layouts, but they are focusing on Compose. So if you're going to use Material Design 3 in your app, you need to switch to Compose, basically. And I like Material Design, especially the new version, the 3.1, which basically adapts the colors based on settings on your phone. So it's a big step up, I think. But another cool thing they added recently for Material Design is Relay. It's a plugin for Figma. Basically, your designers work in Figma. They mostly do these days. But from Figma, you can export the Figma designs, and you can get composables, like UI composables. And I know that exists for other types of UI frameworks as well, but this one is actually very, very useful, and it's only in beta. You can actually start using this today. The way it works, in Android Studio, you say import packages, you give it the URL to your Figma design, where it downloads a file. When you build your app, and once you have imported, it generates. Is this one behind me? There we go. That's weird. Okay. So what it does is it generates a bunch of files in your project. It's a JSON file containing configuration. There are the images, etc. And once you build your application, it generates Kotlin code for you. That is, there are those composables that you want to use. So yeah, if you haven't tried this out, I recommend doing it. I was very impressed. So of course there are some quirks because it's still in beta, but they're working a lot on this right now. Dependency injection. How many here likes dependency injection in any form? So, yeah. Any application that grows in size will need a dependency injection, because otherwise you just have so much coupling between your components. In Android, there are today 2 ways to do it. Well, there are more ways, but the 2 main modern solutions. Let's start with the one from Google. It's called Hilt. So basically, you just annotate a class or an object. You say this one should be a singleton. In this case, it's a singleton, so it could be something that's created whenever it's needed. And I have a repository I want to return here, the weather repo, and also a DAO, which is a data access object, which writes to my local database. And yeah, well, that's fine. So it used to be much more complex if you were using Dagger. Hilt builds on top of Dagger. And all you need in your rest of your application to get this running is basically annotate your app class with a Hilt Android app, and it will generate all the rest of the boilerplate for you. When you want to use this, let's say in our view model, all you need to do is this. You just annotate your view model with Hilt view model. You add the inject annotation to the constructor, and it will just give this to your class. And this makes your view model much easier to test. So yeah, big win for all. Coin is the second one. I don't want to misuse the word dependency injection because coin is actually more of a service locator pattern. But it doesn't really matter. It still belongs in the same area of architecture. But this is how you wire it up. You create a module, which is a function in the coin library. And there you can say single off. It will be as a single instance of this one, basically a singleton. And then in your application, application class in onCreate, you say start coin. You give the context, which is the base thing that it needs. And then you point to the modules. And whenever you want to do injection somewhere, what you do is you use the inject function from coin, and it will just lazily inject whatever dependency you need first time you call it. There is also a get, which will synchronously inject something into a class. I recommend using inject because that will make your application startup time faster. We can argue all day about whether you should use coin or Hilt. There is a big divide in the Android community. It's very fun to watch. I would say use whatever you feel comfortable with. With dependency injection, we come to the final, well, not the final, the important part of architecture. And anyone done Android for a long time know that Google, for a very long time, did not have an opinion on how you should build Android applications. They say, it's up to you. Do whatever pattern you want. Use whatever spaghetti code that you're comfortable with. And, well, it was rather messy, actually. So people misunderstood how the APIs worked, and then they promoted an architecture that didn't really work well, et cetera, So Google were like, yeah, maybe we should tell them how it works and how they should be doing it so they don't misunderstand the platform or misuse activities and the platform APIs. And they did. And this is the result. Basically, you have the UI layer, we have your domain layer, which is optional. You only need the domain layer when your application grows in complexity. And then you have your data layer. Diving into details, the UI layer, this is where your view models and your UI components end up. View models belong in the UI layer. That might be controversial to some people, but that's how Google says today. The data layer, we skip the domain layer because it's just basically something that is used for reusing functionality that many view models share. But if you have a less complicated application, you can do with just the UI layer and the data layer and have your repositories here, and then the database or network calls, whatever, in the same layer there. This might sound like very obvious, but you should see the type of architectures that we've been doing. If you're using MVVM or MVI or MVC, etc., that's less important. The important thing is that you make a clear division here. Preferably, the UI layer and the data layer should exist in separate Gradle modules, so separate source sets. It makes things much more cleaner and easier to work with. It can also speed up compile time if you do it right. And they actually even added a page on the Android developer site for recommendations for Android architecture. I didn't believe it when I saw it. It's very not like Google to do that. And it's also very not like Google to say strongly recommended. They usually don't use that strong words for how you should write software. If you haven't read this one, I strongly recommend that you do. It's very good to get up to date that on to understand why they recommend certain patterns and certain solutions for writing Android. So yeah, check that one out. Testing. And testing is important. We all write tests all the time, right? Oh, you do? Okay. Yeah, most of us who have been doing Android, we have sort of stopped at unit testing. Maybe we did a few integration tests, but most of the testing has been focused on unit testing because UI testing in Android has been complicated. Error-prone, hard to do. Well, that goes for any client-side testing, basically. Doesn't matter if you're doing React or Flutter or whatever platform, UI testing is difficult. They made a lot of improvement for Android. And how do you write tests, UI tests on Android today? Well, with Compose, this is all you need. You add a test rule. Anyone used JUnit know what the test rules are. There is a Compose test rule that you create like that. You annotate it like that. and then you annotate your test method, and then you have a set content function on your compose test rule, which does the same thing as just rendering a compose thing. The nice thing about this is that you can render just parts of the UI, just a single component, and test that one in a UI test. Because what it does underneath is it starts a custom activity, uses your compose code, and shows that component, and then you can click on it, etc. So in this case here, I check whether that text is visible or not inside my city card there. So yeah, it's a lot. I meet a lot of Android developers who still believe that writing UI tests is very, very slow task and error-prone and hard to do. Not anymore when you're using Compose. So highly recommended to check this out. Which moves us to takes us to one of the last things. It's GitHub Actions for Android. Anyone here used GitHub Actions for Android yet? No, well, a few. Oh, yeah, a few. So it's pretty cool how they added this. The regular GitHub Actions have for building Android applications have existed for some time, but we haven't had. It's fairly recently when they came out with something that you could actually run UI tests as well. Because running UI tests requires an emulator. So there was a lot of things that needed to be done in the background first. Because running an emulator in a virtual machine in the cloud is slow. But it's much faster now. What you do, you go to the GitHub Actions, you search for Android CI, you find this one, and well, you add that one, and that one just adds the build tools for you. Now there is another plugin, the Android emulator runner. If you click that use latest version, it actually gives you the code to add to your YAML file. And voila, you have everything you need for running all your UI tests. You might need to change the API level, etc., but more or less this one is free out of the box to get your UI tests running on GitHub Actions. Sure, it's not as fast as if you would do React, but it is much, much better than it used to be, I can tell you. Okay, that was 35 minutes almost. So yeah, to sum this up, Kotlin is pretty awesome. Everyone should try Kotlin because it's such a nice way to write code, to say the least. And even if you don't do Android, if you're doing backend development in Java, you try it out. You can use Kotlin and Java together on backend without any problems. It saves a ton of time. It makes your code less error-prone. So just try it out. And with that, I want to thank you everyone for listening. And I think we have a few moments for questions, but